Today I'm going to show you the photoelectric effect using the apparatus shown here, which was developed by the physicists Heinrich Hertz and Wilhelm Hallwachs. As always, I built the apparatus myself. Let's take a look at the build. The first thing I did was to make a needle electroscope. I used a carbon fiber rod with a diameter of 4 mm as the needle. The scale was drawn with Inkscape and then printed on a self-adhesive vinyl film. Next, the grid and zinc electrodes were made. For the photo emission of electrons from a zinc plate, shortwave UV light is required. To do this, I first bought a lamp holder for E27 sockets and a power cable with an on-off switch. The best choice of a UV light source is here a mercury vapor lamp. I bought one with 25 watts, which emits mainly at 254 nanometers and can be operated directly with 230 volts AC. The lamp should be used with caution. The UV light produced can cause acute damage to the eyes and can lead to severe sunburns. Ozone is also produced. To prevent the UV light from spreading in all directions, I built a reflector from an aluminium tube and an aluminium disc. Once again, I used a plastic kitchen board as a base plate and rubber feet to prevent it from slipping. Next, two glass plate holders were needed to mount a glass plate in front of the UV lamp. The last step was to make two connection cables with banana plugs and a crocodile clip. The glass plate had also arrived in the meantime. Let's move on to the experiment. A PVC rod and a glass made of sheep's wool are used to charge the zinc plate. PVC has a greater electronegativity than wool. The PVC rod is charged negatively, the wool positively. In the past, cat fur was used instead of sheep's wool. However, my cat couldn't be persuaded to take part in the experiment. If the UV lamp is now switched on, nothing happens at first, as the glass plate blocks the shortwave UV light. If the glass plate is removed, the zinc plate discharges due to the photoelectric effect. And again. Let's take a closer look. The electrons are dislodged only when the light exceeds a certain frequency, regardless of the light's intensity or duration of exposure. The electrostatic potential, which is several kilovolts, causes the electrons to move to the grid electrode. This discharges the zinc plate, which becomes visible on the electroscope. The photoelectric effect couldn't be explained by the physics of the time, as after centuries of dispute, it was finally agreed that light is not a corpuscular phenomenon, but a wave propagating through space. However, wave theory couldn't explain that a certain amount of energy is required to dislodge an electron, nor was it possible to explain that electrons are not dislodged even when the intensity of low-frequency light is increased. It was not until 1905 that Albert Einstein was able to conclusively explain the photoelectric effect by assuming that a beam of light is not a wave propagating through space, but a swarm of discrete energy packets, which he called light quanta, and which are known today as photons. Thanks for watching. Stay true, stay you.